So we have a system as shown in this figure, M1 object, M2 object, and the pulley has a mass M and it has a radius. So this pulley is basically like disk. It's not empty basically. So question, find acceleration of this system, and also we can find tension in the rope. So first of all, since this is a dynamics question, dynamics problem, we need to draw free body diagram for each object. First step is very simple. M1G downward, upward we have a T1, here we have a M2G, upward we have a T2. In this case, tension at both sides are not equal to each other because of the mass of the pulley. How we can understand that tension is not equal to each other? Basically, we need to pay attention to this pulley. We know that this pulley rotates in this direction. In order to rotate it, forces at this side and at this side should be different. Otherwise, it will not rotate. If you assume that here and here we have the same tension, then this pulley will not rotate because same force. But we know that it should rotate in order to move M1 and M2. From here we understand that tension of the ropes in the ropes are not same. So here we have a T1, here we have a T2. So Newton's second law for the first object, M1G minus T1 equal to M1A, because it's moving downward. Newton's second law for the second object, T2 minus M2G equal to M2A. They have the same acceleration because we have an inextensible rope or string. So in this equation we have three unknowns: acceleration, T1, T2. But we have only two equations. So one equation is missing in order to solve this physics problem. So we need to write Newton's second law for the pulley. So in this case we need to write in terms of torque because pulley is rotating. T1 times radius, this is the torque of the T1 minus torque of the T2 because it wants to rotate it in anti-clockwise. This should be equal to moment of inertia times angular acceleration of the pulley. So let me continue with the last equation. Moment of inertia of this pulley equal to mr square over 2 because it's a disk times angular acceleration. In this case, angular acceleration equal to acceleration over radius. So let's see. One of the radius will be cancelled. This one also we can cancel it. So T1 minus T2 equal to MA over 2. So basically we have three equations. This one, and the last one. Now we have a third equation. It means we can solve this problem. So further is totally pure mass. We solved this problem in terms of physics, and I think that these three equations are enough to finish this problem. So from first equation, T1 equal to M1G minus M1A. From second equation, T2 equal to M2G plus M2A. And I will copy third equation, T1 minus T2 equal to MA over 2. So I will substitute T1 and the T2 into this equation. So we should be careful. T1 M1G minus M1A minus T2 M2G minus M2A equal to MA over 2. So basically M1 minus M2 G equal to A m over 2 plus m1 plus m2. So from here, acceleration equal to 1 plus m2 m over 2. So this is acceleration of this system. Now you can easily find T1 and the T2 because we have a acceleration here.